Hi, it's my presentation. These are the items I will present. Applications of derivatives to cost function, revenue functions, and profit functions. Use Washer method to find volume of a solid of revolution. Moment and center of mass. The cost function represents the total cost incurred by a firm to produce a certain level of output. It typically includes fixed cost and variable cost. The derivative of the cost function with respect to output is called the marginal cost. It shows the additional cost incurred by producing one more unit of output. And now suppose that the cost function for a manufacturer is given by Cx. So we can calculate the derivative of Cx and then draw the graph of Cx and C prime x. Since the graph shown is the graph of the derivative of Cx, we can see that C prime x is never zero, so there are no relative extreme points. Since C prime x is always positive, Cx is always increasing. Moreover, since C prime x decreases for x less than 1000 and increases for x greater than 1000, we see that Cx is concave down for x less than 1000 and concave up for x greater than 1000 and has an inflection point at x equal to 1000. The revenue function represents the total revenue a firm earns from selling its products, and it is the product of the price per unit and the quantity sold. The derivative of the revenue function gives the marginal revenue, which is the additional revenue from selling one more unit of output. Marginal revenue is important for understanding the impacts of changes in output on total revenue. Suppose that the demand equation for a certain product is P equal to 6 minus 1 over 2 x dollars. In this case, we can get the revenue function Rx, and the derivative of Rx is 6 minus x, and we can draw the graph of revenue function. The graph of x is a parabola that opens downward. It has a horizontal tangent precisely at those x for which are x equal to 0. That is, for those x at which marginal revenue is 0, the only such x is x equal to 6. The corresponding value of revenue is $18. The profit function represents the difference between total revenue and total cost. The derivative of profit functions gives a marginal profit, which is the change in profit from producing and selling one more unit of output. And suppose that we have revenue function and cost function now. So we can get a profit function. The derivative of Px profit function as follow. And we can draw the profit function. So P prime x equal to 0 when x equal to 2500. The profit for this level of production is $52,500. The Washer method is typically used when a region is revolved around an axis, creating a solid that has a hole in the middle. The method works by subtracting the volume of the inner region from the volume of the outer region. If the region is bounded by two functions, fx, and gx, and the region is revolved around the x-axis between x equal to a and x equal to b. The volume of the solid can be found using the following formula. And suppose that the volume of the solid generated by revolving the region bounded by parabola y equal to x squared and y squared equal to 8x about the x-axis. Therefore, we have following formula. And the solution is 48 pi over 5. The point on which the thin plate of any given shape balances is called the center of mass of the plate. The product of the mass m of a particle and its directed distance from a point is called the moment of the particle with respect to that point. For a system of particles, a center of mass of the system of n masses m1, m2 to mn located at the point x1, y1, x2, y2 to xn, yn in the xy plane is following formulas. For example, the moment and center of mass of a system of objects that have masses 3, 4, and 8 at the points -1, 1, 2, -1, and 3, 2, respectively. And we can calculate the my, mx, x bar, and y bar. So we can get the center of mass is 29 over 15, 1. From continuous mass distributions, the center of mass can be found using integrals over the mass distribution. We will want to find the center of mass of a semicircular plate of radius 2. We need to use integrals. By the symmetry principle, x bar equal to 0, a equal to 2 pi, and we can calculate mx and y bar. So the center of the mass is 0, 8 over 3 pi. That's all the things I want to present. Thank you.